Hi, welcome to my project bazaar.com. Now we are going to see the process of trees cannot lie using data structures for forensics purposes. Here is the abstract of our process. The databases are primarily focused on logging mechanisms and artifacts accessible in the database management system. While log files, plant catches, catch clock, hands, etc. can reveal past transactions, a malicious administration modifications might be more difficult to detect because he can cover his tracks by also manipulating the log files and flushing transient artifacts such as caches. The internal structure of the data storage inside database, however, has not yet retrieved much attention from the digital forensic research community. In this process, we want to show the diversity of B plus trees, a widely used data structure in database storage engines, enables a deep insight of the database history. Hidden manipulations such as predated insert operations in a login database can be revealed by our approach, and also to introduce a novel forensic techniques for B plus trees that are based on characteristics of the tree structure, and also how database management system could be modified to even better support through tree forensic techniques. So it's well used in insert, update, and deletion operation. Once the tree structure should not be modified without any authority, so it provides much flexible to the database management system. Let's move to one DFT of our process. Here we use the input dataset. The input dataset as a census dataset. The census details contains name and also age and also the incoming details and also the occupation and also the married life. These all the details are input in the census dataset. Then moves to the dataset pre-processing stage. In dataset pre-processing stage, we have to find any missing values present in the database. And if it is present means we have to recover the data and fill the attributes in the database. Then moves to the feature evaluation process. In feature evaluation process, we have to get the unique ID of attributes in the database. The unique ID represents that means the employee ID, so that ID will be evaluated. Then moves to the B plus tree formation. In B plus tree formation, the first of all the considers the root node as a root node, and the left node as a child node, and the right node as also child node. These are the B plus tree formation. Then we call tree structure. So the tree structure will be formulated based on the B plus tree formation process. Then moves to one tree instruction process. In the tree instruction, if you have to insert any new element in the tree means it is denoted as value as 1. And also we have to update. If you have to search or the any ID presence in the tree means we have to search the value into the tree structure means if it is present means it is denoted as 1, otherwise it is denoted as false or 0. Then to tree deletion. If you want to delete any content in the dataset means you have to give the ID details. If you give ID number 2 means if ID present in the datasets means it is deleted, otherwise it represents as false. Then moves to the performance evaluation process. In performance evaluation, we have to evaluate the execution time and memory optimizations for tree structure formation and insertion and updation and deletion. Therefore, we show the better efficiency in our process. Let's move to one demo of our process. Here is the home page of our process. Here by clicking choose dataset, we have to select the input dataset in our process. The input dataset is a census dataset. Then by clicking load data bit, the data are successfully loaded. Then moves to process. Here by clicking census, by clicking show means this is the overall dataset in our process. Employee ID, age, class, education, marital status, occupation, relation. These are the attributes used in our datasets. Then move to process. Here by clicking tree structure means these are the B plus tree formation structure and also the rule formation. How to format the B plus tree? First it's root node and contains B element and the left node and also the right node. Then moves to tree structure. Get employee ID details. So the overall ID details of employee are displayed here. Then called tree structure. Based on the employee ID, we have to formulate the tree structure basis size 2 and also the substructure. Then B tree structure. Here by clicking make tree means employee ID based tree formation will be evaluated. That is root node and also left child and right child. By clicking root node means here the root nodes are displayed here. One root node left attributes. Here the root node 4 means the left attributes are also displayed and right attributes are also displayed. Then moves to insert process. Here get ID from tree means the overall employee ID displayed. Here we have to insert new elements with type the content name here. By clicking 35 means the new element is inserted by clicking insert process. So the element retrieved and added in the process. The new element is added. Then moves to next process. Here by clicking find elements, give any elements in the tree formation. Data searched successfully. So the 43 denotes 1 means it is presented in the B plus tree formation. Then updated B tree list. Here is the updated B tree list. Then moves to next process. Updated means the overall insert and new element presence in the updated list are shown here. Then move to next process. Here by clicking records list means nodes listed. Here click 43 means so here shows the subtree left of the tree and subtree right of the process. We selected the node list employee ID is 43. So the left of the employee ID details are here and the right of the child details are here. Then moves to process. Here by clicking give and delete records means give any other records. 45 means by clicking delete records means the data deleted successfully. Here by clicking updated means data updated successfully. Here we have to check that 45 is not present here because the data is deleted here. So the B plus tree operation successfully done insertion, deletion and searching process. Then moves to graph. Here the graph represents the execution time of our process. Insertion takes this amount of time in and searching and deletion process. Then processing memory. The processing memory optimization for insertion, search and deletion operations shown here. Thank you.